So in this notebook, we will reduce data we just simulate. So the introduction is the same as previous. So we use two different simulate data. So first, previously, I have simulate for all the detector and all the deezer in the image we used. So with the filter 140M. And I also simulate with long wavelengths, so 335M, using another image. So all these data are on normally on your directory to be used in this notebook. So first you can see the different documentation as previous. So you need to install on your laptop the package JWST. So as for MIRAGE, is installed on the platform, but if you want to use this script by your own, you need to install this one using pip install and create a new environment. You also need the reference file, so the CRDS contents. The same as previous, but you haven't to add the MIRAGE data. And if you have already used these different paths, you can see this one has changed. So in fact, if you use the development version of the pipeline, you have to use this link to the CRDS server. But if you use the latest versions, you have to use this one. And if you want more information on this, you can go on the documentations. So here we create our different variable, and not worry if it's red here. It's just because the file already exists, because normally you have downloaded it on the previous notebook. So we need to import the JWST package, the fits and the glob to global data, and to import matplotlib. You can check the version of the pipeline you used. So here it's not the last one because the script haven't been tested on the last one when I created. So sorry for that. And we use a function to show our different stage. So the pipeline to reduce the data is composed by 3 different stages. So the first one removes the detector issues, so like the vertical strip of the previous image, and create the rate data. The second stage calibrates the exposures and converts the units and create cal data. And the last one combined and rectified different exposures. So it's the stage to combine different deezers or different modules to create a mosaic. And the final data is I2D. And you can use so the data from MIRAGE that correspond to the pipeline format. So for the short wavelengths, we use the detector A1, A2, A3, A4, etc. But as our scene image is too small, we only have observation on the module B. So here we only use the module B. So the first step is detector processing. So this step is common to all the instruments and all the modes. So you use the same one for imaging or spectroscopy, for example. You need a raw exposure, so with extension and cal. So same we create. I forgot to precise, but there is different way to call the pipeline. Here we only use one way in Python, but on the documentation you can find the two other way to run the pipeline. So yes, and in this stage we'll produce two different images. So one 3D image containing the result for each integrations, and one 2D image containing the average of each exposure integrations. But as here we only have one integration, the two files are the same, so we only use the right one. So we have to define the path of our raw data. And then we create a function to call our pipeline. So first we need to instantiate the first stage. So using detector one pipeline. Then you can specify if you want to this one first. If you want to save data, so yes, we want to save the rate file. Then you can specify the output directory. Or here it's in the output directory here. And then to prevent saturation, so we just change here. So sorry. So yeah, in fact, there is two, as we have only two groups, we choose to count on the dual groups and not suppress one. So for this, we set this parameter to false to have all our groups. And then you can run the pipeline on your file. So this is the function we use after. So we need your file on your NCAL file. So here we just do the different stage on the B1 detector, because if we do this on all the different detector, it will be too long, and we haven't this time. And we create a different path to store our weight data. So then you can run on all the raw data on the yes. So we make a for loop, and then run on this. So on the file F, and we want to store this in the path stage 1. So here you have also the log, and it will be done for all the vocal we choose, so independently. So if you have time, you can parallelize this stage to gain some time. And So yes, there is a lot of log. But after, for the two other stage, you can run the pipeline on an associating file and not in a for loop. For the stage 2 is as you want, and for the stage 3 you haven't the choice. So if you look in the output, sorry, so you can see there is stage 1 and you can see the data are created. So then we choose to look the result on one data, on one file. So we show our weight data. Here you have to tell the unit. So here it's ADU by sec and choose the max. So this is the image we simulate, but without the detector effect. So there is not the stripe here, and the image is better. But you can see some issues like here, some line, some black point, and other. So this will be corrected in the other stage. So after you can use stage 2 image processing. So here it's a different stage if you use an image or a cube. So here we use image 2 pipeline. So you only need the rate file, and then it will be create a calibrating file, but unrectified, and also a rectified file. But at this stage, the rectified file is used only for a quick look, not to. It shouldn't be used for science. You have to pass it to pass through the third stage. So here we create. So in this stage, sorry, we also remove some instrumental signature, and we calibrate exposure to have image in MIRAGE per steradian. So as previously, you have to instantiate your pipeline. So with image 2 pipeline, you also have to specify the output directory. So it's same. And to specify if you want to save your results. So yes, we want. And then run the pipeline on your file. So in fact, here you can choose all the parameters you want. So here we used a lot of default parameter because it works in your case. But on the documentation, you can find all the different arguments you can use if you want to choose them. So then we use the rate data, and as previous, you can run it on your rate file. And you run image 2 on your file and on the path stage 2. So we create and then run. So we create different paths for each stage to be more convenient to find the different results. So here the stage 2 is created, and we have to wait until it's done. And after, well, we will also plot our image here, up, so the scale data, tilt. Now our calibrating image is in JWST first region, and we choose as maximum, choose this one. So we have to wait during the reducing, so you can see the different parameter create here. Log to scroll. So then you can, yes, it's done. So you can choose your data and plot here. Sorry. So it's the same image as previous, and you can see it's calibrating, and here there is no more line. So the image is a little corrected. Yes. After we have the last stage. So the image free pipeline. So in this stage, you can and combine multiple exposure. So as you want, different teasers, different module, or all teaser and all module, and create one final mosaic corresponding to the final product. But to use this stage, you have to create an associations file to combine all your data. And this stage will create the final image, but also a cosmic ray flagged exposure, a source catalog, and a segmentation map. So first we have to create your association files to combine your multiple exposures. So it's written in a JSON file, and you have the function assign from list to create our associations file. So we create another functions. So here it's to create an association file for each detector, and here it's to create for all the teaser and all detectors. So you have to glob all the data you want. Choose the name of your final image, and then you can use another functions to create your association file. So here it's the file you want to combine. Here it's the rule used. So if you want to use this for the stage 2, you can just change level 3 in level 2. Here it's the product name, so corresponding to the name of your final image. So then you can create the functions as previous. So yes, here we have to instantiate your pipeline. So it's image 3 pipeline. So as previously, you have to choose your output directory. Say if you want to save your result. And here we skip the triggering options because if this option is true, you will combine two different teasers and then combine the first image with the first one and the fourth image with the first one. But if this option is turned off, you will be combining the first image with the second one, and then the third one with the combination of the two previous one. So as we have poor alignment in your teasers, it's better for us if we combine with the combined one. So we skip these options. And then, as previous, you can run on your file name. Yes. Then we create our association file. So normally we have the for detector, but as I explained, it's too long to run on the for detector, so you only have the detector B1. And it's create two association file, one for the detector B1, so the for teaser of detector B1, and one for all the teaser and all the module. So we create also the new stage, and you can run the stage 3. So on the ISN file, so this one, and you can see here the file created. And we want to store it in the stage 3. So it's a bit long, and you can't parallelize different exposure because they have to be combined to create a final mosaic. So after, once it's done, we will see the result and verify there is no more black point or stripe on our image. And I also already ran on all the data to just show you the final product, but it was too long to run it. And after we will do this on long wavelengths. And for this, it will be an exercise. So you can test if you have well understand how to do this by your own. But for now, we have to wait until the creations of our final data. So if we look in the stage 3 folder, so there is already the one for the all the teaser and all the detector, so that will plot after. You can plot our final products. So you can see here the pattern of our teasers. And normally there is no more black point. So just here, because you only have one one deezer here, and there is just some saturation on the brightest stars, and that's all. And you can plot the final image combining the 4 detectors. So here, so you have also the dithering pattern here. You can see some saturation on the 2 brightest stars, and you have your final image. And then you can make some science on it. So now we will do this for long wavelengths. So using the detector A5 and B5, and as previous, we only use module B because we only have a simulation for this one. After all the script and the presentation will be available on the website of the webinars. And if you have some, you want to see more details on what we present you, there is my article where I explain what I've done on this notebook. There is a PDRs4 website and the paper presenting by Olivier. And if you have some other questions after this webinar, as I say, you can ask me, ask the help desk or the PDRs4 teams.